Welcome to Ask and Learn.
Taking a look at here is a combustion process where the burning of hexane with excess air generates gas and water. So we can balance the outlet gas dry stream and derive the relationship for the mole fractions as follows. N3 at N4 is equal to 0.907 N2. So we can derive the percent conversion of hexane from an atomic balance of the carbon atoms. So we have C6H14 add O2 generates CO2 add CO add H2O. So what we get is N2, 5666 moles of air exit gas. Then we can calculate the volume of hexane in the dry stream. So the first thing we have is moles, C6H14, sorry, it's not cyclic. We get 0.00265 multiplied by N2. We get a value of 15.0. So from this, we take 100 mole, subtract 15 mole, divided by 100 mole, multiplied by 100% to get 85%. So the conversion of hexane is 85%. Next, we can determine the percentage of excess air in the burner. So we can make the assumption N1 is equal to 1.27 N3. And so what we get is the following. So this relationship is needed at a later point. So we proceed with a hydrogen balance because the total number of moles of the exit gas is now known. And then we can solve for N5. 595 moles of H2O. So we've got a whole list of known values at this point and unknown values. So we can complete an oxygen balance, and then from this we gather that N1 is equal to 3592, add 4.76 of N4. So to determine the excess air, calculate the amount of air that is needed to fully combust 100 moles of hexane, and at full combustion we only have CO2 generated. So that is as follows: C6H14 add O2 generates CO2 add H2O. We then need to balance that out. So we get 7 H2O, 6 CO2, 19 over 2 oxygens. So we have our N moles of theoretical air, 4524. Using 9.5 moles of O2 from the balanced equation that we figured out. And then we get the percentage excess of air, that is the N actual, take away the N theoretical divided by the N theoretical multiplied by 100. 30.6%. So next we can calculate the dew point of the well-stacked gas. So from the balance of both, we know we have 595 moles of water in total. So we have 595 plus 5666, which we calculated earlier. So what we get is P H2O is equal to 595 divided by 595, add 5666 multiplied by 760 millimeters of mercury. We get 45.1 degrees C that we've determined from the table when we get the value 72.2 millimeters of mercury.